Hi everyone, welcome to a short video which is going to look at the k-means clustering analytical theory and how it's applied in R programming. So it's an unsupervised method of collecting data into categories without having them outlined already. So basically, I've done a video already which goes over the k-means theory. However, what k-means does in essence is it takes data and it categorizes it based on information it's found, rather than you having to have categories already set for that data. Obviously this can be very useful if you're looking for things like trends or marketing algorithms. There's loads of different methods you could apply this analytical method into in order to get some useful data. Okay, so as you can see from my screen, I have now got a title at the top which just says unsupervised methods of collecting data into categories without having them outlined. So we are going to use the iris dataset, like so. Okay. The reason I'm going to use the iris dataset is because it's already built into RStudio, and it's just an easy one to get us going. What you should be then doing after you've watched this video, you should be looking at a CSV file, and you should be trying to import that yourself, looking at the other videos we've been over, and then trying to do some analysis with k-means based upon that data. Okay, but for the purposes of this, we're just going to use the iris dataset. So we are going to first load in datasets to our RStudio environment, like so. So we'll libraries, open brackets datasets, and then control and enter to run. Then we are going to specifically load in our iris dataset. So again, control enter, and you'll see in the top right hand corner, we've now loaded this value of iris into there. Okay, and then finally, we are going to do a summary of the iris dataset itself, like so. Okay, and now you'll see in the bottom left hand corner, in the console window, it's loaded up our iris dataset we're going to be using. And then it's got some useful data in there, such as the mean, the median, the different quantiles, the categories based upon the species. So we've got 50 different species. And then if you go to the top right, in our environments, you can double click on that iris dataset and it'll bring it all up there for you to see. Okay, so you'll see, looking over this, we've got 150 different records, each one's slightly different, and it's got the category at the end. Okay, so the reason behind k-means clustering is to categorize data with data that doesn't have categories. Obviously our data here currently does have a category, and it's called species, so we're going to remove that to start off with. So we're going to go to iris dot features, like so, and then we are going to equal that to iris itself. So we're going to create a new data set called iris dot features, and then we're going to give it all of the data which is currently in iris. And then we're going to go control and enter again, and now we've created that data set, as you can see from the top right hand corner. Now we're going to use the iris.features data set again, and in this case we're going to focus on the species column, and we're going to make that equal to null. So all this is doing is it's taking that column within the iris data set here, and it's getting rid of it. So that's what null does. It just says we don't need that anymore, so please lose it. So you'll see now, if you load up the iris features one on the top right, we've now lost that final column. So we've got iris there, and we've got iris features here. Okay, so you could just do that by going on view as well, just so you know. So you could do iris.features like so, and then control enter, and then that will load it up for you. That's basically the same as clicking on here. Okay, so now we've got that data set created for us, we're going to create a new data set called results, and inside that results, we're going to run the function of k-means, and we're going to use our newly created iris features data set in order to do it. And then, as you know, by k-means clustering, we have to define the category number we want ourselves. So we could have 5 different categories, or we can have 3 different categories. In this case, we're going to go for 3. So we're going to create a new data set called results, and inside that we're going to have our k-means function, and it's going to work with the data of iris features that we've created, and it's going to put that data into 3 different categories for us. Okay, and then we are going to look at them results. So if you're on this line, if you press Control and Enter, it'll run that at the bottom, and then Control and Enter again, and it'll show us lots of different information. Okay, so it shows us information such as the k-means clustering sizes, the different means, the vectors themselves and how it separated the data, and then different available components that we could use. So obviously all of that data in mass isn't as useful as it could be. So we're going to focus on a few little areas. So we're going to go results, size, and all this will do is it will pull this line of data for us. So it'll look through the whole of the data with the k-means, and it'll give us that piece of information. So 50, 38, 62. Okay, and all that means is it's the amount of observations within them categories that data has fallen into. Okay, and you'll see it obviously adds up to 100 at the end. So in category 1 we've got 50 pieces of data, in category 2 we've got 38, and in category 3 we've got 62, and so on. Okay, so we will also have results $sign cluster, and what this will do is it'll look at the vectors themselves and where the observations were assigned to within them vectors. So you'll see here within that you've got all that data assigned in the first one, all that data assigned in the second one, and all that data assigned in the third one, and it'll just work it out for us based upon that. This will help us plot the graphs in a second. Okay, so obviously in fact we'll have a quick look at a table first. Let's just do an iris table, an iris species table, like so, and then we will compare that to the result cluster. So what we're going to do is we're just going to compare our original data set, so iris species, so iris up here, species here, and we're going to compare that now to our results cluster, which is this one here. So we're going to compare it to the one we've created after using k-means clustering, and then we will do Control and Enter again, and you'll see now how it's separated it into these categories. So we've got our first set of species, Setosa, and that's put all of their observations into category 1. Then we've got Versicolor, that's put all of their observations into category 3, apart from 2 which are in category 2. And then Virginica, it's put 36 of them into category 2 and 40 into category 3. Okay, so obviously this data is now categorizing the data for us. The k-means cluster is now categorizing the data for us, but it doesn't really mean anything yet until we start to plot the graphs, because obviously, as we've discussed within data analytics, and the visualization element is really, really important. Okay, so we're going to first plot our plotter chart. So we will do plot open brackets, and then we will use iris to start off with, the original one, and then we will in square brackets put 2 different categories, and then these categories will be petal, length, like so, and then they will also have petal width, like so. Put these brackets the wrong way around. So, why am I doing it down here? It's a bit odd, isn't it? Should be doing it up here. I wondered why it wasn't green, confused me for 1 second. So we're going to do the iris, and we're going to have a petal length and petal width, and then inside that we're going to have the colour of results, clusters, like so. Okay, so and then Control Enter to run that, and you'll see on the bottom right hand corner we've now created a small graph which looks at the petal width and petal length, and it categorises these three pieces of data within that set. Okay, so when I was doing it down here before, you could actually run it down there. So you could run this line down here, for instance, and you could run it in there. And if you ran that, it would run the same. But because we're making a script and we're making like, all the script means is putting loads of different pieces of code together to create something we could then use again. It's just easy doing it at the top for us. Okay, so like I said, we've created now a plot and a graph using the iris data set, and it's got two different categories. It's got petal length and petal width. So petal width here, petal length here, and it's categorized it into three different columns, and then it's colorized it based upon these different results that we've generated through our k-means clustering. Okay, so let's just compare that to our original data set. So obviously the one just above, we've got, in fact I'll just copy that over to here, and then instead of using the results cluster, we will just do our iris species like so. And then you'll see when I run this line of code, the colours change very slightly into different ones, different categories. So what this has done, as you can see there, it's showing that our clustering method here in k-means clustering, it's separated into three different categories for us, and they are very similar, if not identical, to the original categories based upon the types of flowers that they are. Okay, so this is just like a check method for our example. Obviously in like real life situations you wouldn't have an example to go back to. It's just showing how the k-means clustering elements would work. Okay, and then we will just do this one again quickly, but because we haven't just used the petal one, we've used the sepal one as well. And then we'll just okay, so we've got our sepal, which is here, which is again, it's a bit of a mixture. There's some overlapping data in there, definitely, and it's a lot less categorised than the petals themselves, but it's still clustered and it's still in the right way. That's based upon our k-means clustering method. And then finally, if we used our the same set of data, the sepal data, we've categorised it based on species, you'll see it again, it's the same, but it's different, just different colours, different categorised, so you can kind of see. So all this is showing here is that our k-means clustering method is a good method to categorise data which doesn't have a category already to start off with, and that's what we mean by unsupervised methods of collecting data. Okay, hopefully this was a nice little short video showing you how to do the applied aspects of k-means clustering. You can obviously go into the k-means clustering itself, and you can run, instead of running the function, you can do it all individually, but for the purposes of what we need, we don't need to do that at this stage. Okay, so hopefully this video was helpful, and it just showed you how to use the k-means clustering within RStudio itself, and some of the reasons why you would use it, and I'll see you in the next session.